So the first thing to remember here is you may have seen older spec sheets or older products that describe their light output for plants in lumens. And this is not appropriate at all. Lumens are for humans, is the way we talk about it in plant world. It weights the light for the human response. And in this case, we really want to make sure that we weight the light for the plant response. And as Sean mentioned, plants have very many photoreceptors, and they really want a broad light distribution so that their photoreceptors can respond appropriately. So one of the most important ways that we describe light with these metrics are for photosynthesis. So the first one we're going to talk about is photosynthetic photon flux. And in this case, what happens is a manufacturer or a testing lab will take the light and put it into an integrating sphere, just like the sphere that we use for measuring commercial lighting. And they will measure all the light that bounces around in the integrating sphere in the PAR range. And when they sum it all up, you get photosynthetic photon flux, or micromoles per second are the units. And so it doesn't weight red differently than blue or green differently than blue. All of the light within the PAR range is counted in that entire sphere. So up light, down light, light that goes to the side. And what you get is a spectral power distribution, or an indication of how much total light you have and what the spectrum of light looks like. Now, if you take that fixture, now that you know the total amount of light, or the PPF, and you now install it into a greenhouse or into a vertical farm, and you install it at a certain mounting height, you now want to measure how much light gets to the top of your canopy, for example, right? And so you do that with a light meter that is weighted for photosynthetic photon flux. And the measurement that you make, say at a specific point, let's say under the light or in between the lights, is called the photosynthetic photon flux density. And this is the units of light for plants, right? Micromoles per second. And now you're going to divide it by meter squared, which is how we measure light, just like lux. It's how we measure light for plants. And you will get a measurement for each point of light, and then you can average that. You can look at the max to min or the minimum to average, and you can look at the quality of light over your canopy. And finally, the last metric that we look at, again, analogous to how we talk about lighting for commercial lighting, is efficacy. In this case, again, we're looking at the photosynthetic photon efficacy, or PPE, and this is the PPF per watt, right? Just like you have lumens per watt, you have PPF per watt, and because of how the units work out, it ends up being a unit of micromole per joule. And in this case, you can look at the efficacy, or the ability of a fixture to efficaciously produce light, compared to, say, an HPS fixture or a different LED fixture. It's a very simple way to compare a fixture's energy efficiency to another fixture, and then you can look at how well it performs in the application.